Welcome everyone once again to Maths by Gurpreet Sekho, where maths is made easy by me, hopefully easy for you as well. So we were doing second chapter, that is polynomials of ninth class, and the concept that we are going to discuss today is the concept of algebraic identities. This is very easy concept. You just have to apply the identities which you have been learning from since your 7th class, 8th class, and all the identities are very easy. So don't worry, and we will apply identities turn by turn. Firstly, very basic identities, and you also know these identities like x plus y whole square. It's x square plus 2xy plus y square. The second one is x minus y square, that is x square minus 2xy plus y square. Third one can be x square minus y square, which is equals to x minus y x plus y. Fourth can be x plus a and x plus b, which is simply is equals to x square plus ax plus bx, that is a plus b x plus ab. Alright, we will apply these identities to solve our examples. Easy. Alright, firstly example 16. The first part is that we have to multiply these two terms using identities. Now you can easily see that x plus 3 multiply x plus 3, we can write x plus 3 whole square. We can apply the identity number 1, x square plus 2 multiply x multiply 3 plus 3 square. You will get x square plus 6x plus 9. Alright, in the second part we have to evaluate. I am going on a fast track because this is very easy concept and most of you are familiar with these kind of identities. Alright, so you must not feel bored according to me. That's why I am just being fast. Now x minus 3 and x plus 5. Now it's x plus a and x plus b type. How you can write that x plus minus 3 and x plus 5. What was the identity? That was identity number 4. You can write x square plus a plus b. What is a minus 3? What is b plus 5? X plus ab. What was a minus 3? What was b? 5. X square plus 2x minus 15. This is our required answer. Alright, let's move to next example. That is example 17th. We have to evaluate 105 multiply 106 without multiplying directly. You have to multiply, but you have not to multiply directly. So what will you use? You will use the nearest whole number ratio. Like the nearest one is 100. You can write it as 100 plus 5. And for this you can write like 100 plus 6. Clear? So 100 plus 5 and 100 plus 6. It can become x plus a x plus b, where x is 100 because it's same and a and b are different. So directly apply the identity 100 square plus what is a 5, what is b 6, and then 100, then plus 5 multiply 6. What will you get? 10000 plus 1100 plus 30, and after adding you will get 11130. So there are a lot of sums like this that you have to multiply without actually multiplying. So in those cases you have to just use the nearest whole number. Like in this case it was 100, it can be 10, it can be 1000 as well. Okay, you have to take care that the number on this place must be same in both of the brackets, because only then you will be able to apply the identity x plus a multiply x plus b. So example number 18 says that you have to factorize 49a square plus 70ab plus 25b square. Right? Now here is the thing. So far we have applied the identities and we have used the left hand side of the identities to reach to the right hand side of the identities. Now we will use the right hand side of the identities to reach to the left side. So firstly convert these to their perfect squares. Now 49 is a perfect square, that is we can write it as 7a whole square plus, leave 70ab for now, 25 can be written as 5b square. right? Now this is looking like x square plus 2xy plus y square, right? So what is x? That is 7a. What is y? That is 5b. So this is x square plus 2. What is x? 7a. What is y? That is 5b plus y square. That is 5b whole square, right? So you can see that 2 sevens are 14 and 14 fives are 70. So it's becoming the same term. We have not disturbed the sequence of the statement. All right. Now a square plus 2ab plus b square, it becomes a plus b whole square. It means 7a plus 5b whole square. But what did we have to do? We have to factorize. So just expand it a bit, split the square, you will get the two factors as these: 7a plus 5b, 7a plus 5b. All right. In the second part, we again have to factorize using the identities. 25 upon 4x square minus y square upon 9. It's also similar. Convert these to their perfect squares. 5 upon 2x whole square minus y upon 3 whole square. This is looking like x square minus y square identity. And what was the result? X minus y, x plus y. It means 5 by 2 x minus y by 3 and 5 by 2 x plus y by 3, right? It was the result: a minus b and a plus b, or x minus y multiply x plus y. So these are the factors, and you have successfully factorized the given term using identities. This was very easy. Just apply the identities. You have to remember the identities only, and then you can apply as soon as you see a familiar situation in which the identity can be applied. So let's move further. Our next identity which is to be used is identity number 5th, and it is x plus y plus z whole square. It's equal to x square plus y square plus z square plus 2xy plus 2yz plus 2zx. Now we will apply this identity to the upcoming examples. So example number 19th is stating we have to write 3a plus 4b plus 5c whole square in the expanded form. And what does it mean? Indirectly, we have to apply the simple identity. So just compare it in easy way: x, y and z. So x square, it means 3a whole square. Y square, it means 4b whole square. Z square means 5c whole square plus 2xy, that is 3a multiply 4b plus 2yz, that is 4b multiply 5c. Let me write x, y and z for your ease. So plus 2zx, that is 5c multiply 3a. Just multiply it and just take care that you don't make a mistake while doing calculations. 3a square, that is 9a square plus 16b square plus 25c square plus 2 3s are 6, 4s are 24, 24ab plus 2 4s are 8, 5s are 40, 40bc plus 2 5s are 10, 3s are 30, 30ac. This is your required expanded form. All right. Let's move to next example, 20th. In this example, we have to expand 4a minus 2b minus 3c whole square. Now, some of you must have been wondering that we have done the identity in which there were only plus signs, but here it is minus. So don't worry about that. Just convert it like this: plus of minus 2b plus of minus 3c whole square. This is your x, this is your y, this is your z. Just apply the identity: 4a square plus minus 2b square plus minus 3c square. Now you have to take care of the signs. 2xy, it means 2, 4a and minus 2b plus 2yz, it means minus 2b minus 3c plus 2zx, it means minus 3c and 4a, right? 16a square plus 4b square plus 9c square. 2 4s are 8, 2s are 16 minus 16ab, right? minus minus plus, 2 2s are 4 3s are 12, plus 12 BC, 2 3s are 6, 6 4s are 24, minus 24 AC, right? So in this way you have to factorize, and this is how you expand the terms using given identities. Now we have moved from left hand side to right hand side. Again, let's move from right to left hand side using the next example, that is 21st. We have to factorize. Now factorize means we have to go in the reverse process. The polynomial or the term is given 4x square plus y square plus z square minus 4xy minus 2yz plus 4xz, right? So 4x square. Now it's looking like a square plus b square plus c square plus 2ab plus 2bc plus 2ac, right? So firstly convert it to the square. 2x square plus y square itself plus z square itself. All right. Now this is our a square, this is b, or you can say this is x, this is y, this is z. What was the next term? 2xy plus of 2xy. Now what is x? That is 2x. What is y? That is y. We also have to adjust the negative sign as well. So you can take negative sign with any of the term, like you can take y negative and you can take x negative, but we will see. Firstly, let's write the next term as well, plus 2yz. What is y? Y is y and z is also z. Now here you can see that y is common and there are before these both terms there is subtraction sign. It means y is having the subtraction sign. Alright, so that is why I did not put the subtraction sign before, and I told you to write the next term first. Now 4xz plus of 2. What is x? That is 2x. What is z? That is z. Now if x would have been carrying negative sign, then there must be negative sign. So that means our sum is right. Now x square plus y square plus z square plus 2xy plus 2yz plus 2xz means 2x plus y plus z whole square, right? Now here y is our negative y, so we can write it as like this as well, that 2x minus y plus z multiply 2x minus y plus z, right? So we have factorized it, we have made the factors. Now there are only 2 or 3 identities remaining and the examples related to them. So let's just do that and finish the exercise. Identity number 6 is a cubic identity. It states that x plus y whole cube is equals to x cube plus y cube plus 3xy x plus y. You can see that these identities form the basis of mathematics. So that is why you must keep these identities in your mind, no matter you are doing graduation or you are in 9th standard or 12th standard. These are being used everywhere. Identity 7th is the same cubic identity with the subtraction sign. It's equal to x cube minus 3x square y plus 3x y square minus y cube. Or you can say, if you want to write it in this form, you can write x cube minus y cube minus 3xy x minus y. It means you just have to replace y with minus y, the rest of the identity will be similar. So let's apply these identities. What will we get? Examples 22nd, and the first part, that is 3a plus 4b whole cube. Now this is our x, this is our y. Simply it's x plus y whole cube. Apply the identity. 3a cube plus 4b cube plus 3 multiply 3a multiply 4b multiply 3a plus 4b, right? You will get 9 3s are 27, 27a cube, 4 4s are 16, 4s are 64 b cube, 3 3s are 9, 4s are 36 ab and 3a plus 4b. 27a cube plus 64b cube. Now you will get 36 3s are 108, 36 or 108, write simply 108 here, 108a square b plus 144ab square. because 36 fours are 144, right? So we have expanded it very easily. In this second part, we have to expand 5p minus 3q whole cube. Now this is our x, this is our y. Simply apply the identity number 7th, this one, 5p whole cube minus 3q whole cube minus 3 5p 3q and 5p minus 3q, right? You can compare simultaneously. You will get 125p cube minus 27q cube minus 3 5s are 15, 3s are 45pq 5p minus 3q. Multiply it inside the bracket, 125p cube minus 27q cube. You will get minus 225p square q and plus of 135p q square. This is how we can expand using the identities 6th and 7th. Now we'll do a sum which is related to using the nearest whole numbers. That is, in example 23, we have to expand, or we have to evaluate 104 cube. Simply 104 cube. We can write it as 100 plus 4 cube. Again, you have to use the nearest whole number. 100 plus 4 cube. It means x plus y cube, right? So use the identity x cube. It means 100 cube plus y cube. It means 4 cube plus 3 multiply 100 multiply 4 multiply 100 plus 4, right? 100 cube, that is 1 0 0 0 0 and 0 0 plus 64 plus 304s are 1200 multiply 104 1 0 0 0 0 0 0 plus 64 1200 104s are 124 800, and after solving you will get 1124864, right? This is how you have to solve sums like these. Now here is one more sum like this. In the second part, you have to solve 999 cube. Now the nearest whole number is 1000, but you cannot add 1000 or add anything else to 1000, but you can subtract 1 from 1000. You can write it as 1000 minus 1 cube, right? So x minus y, this is your x, this is your y. Apply the identity x cube. That means 1000 cube minus 1 cube minus 3 multiply 1000 multiply 1 and 1000 minus 1. So 1000 cube, it means 1000, then again 000, then again 000, minus 1 minus 3000, which is getting multiplied by 999, and after solving the equation you will get 997002999. You can solve it very easily. You know how to add and subtract things, right? So this is how to solve the questions like these, 104 999, in which we have to use the nearest whole numbers. Okay, so let's move to the next example and see if there are any identities remaining. Now in this we have to factorize the given term, given equation or polynomial, and the thing here is that you have to go from right hand side to left hand side of the identity again. It's looking like a cube plus b cube plus 3a square b plus 3ab square, right? So just reduce these to the perfect cubes. What will you get? 2x cube plus 3y cube plus, now just this is our x cube, this is our y cube, and what was the next term? 3x square y. So 3 means 2x square and the y means 3y, and the next term was 3xy square plus 3. What is x? That is 2x. What is y? That is 3y square. Now when you will solve this, you will get the desired numbers. So we have not changed the equation, we have just simplified it a bit. Clear? So now this is a cube plus b cube plus 3a square b plus 3ab square, and what is a and b? That is 2x and 3y. It means 2x plus 3y cube is our required identity, and we want to decipher it into the factors only. So 2x plus 3y, again 2x plus 3y, and again 2x plus 3y. So these are the three factors which we have got from the identity of cube. Alright, so now here is the last identity as well as the last example. The identity is a bit longer. this is x cube plus y cube plus z cube minus 3xyz. So it is equal to x plus y plus z, then x square plus y square plus z square minus xy minus yz minus zx. This is the identity. This is a bit longer and this is not very commonly and oftenly used. So using this, we have to factorize our example 25th, that is 8x cube plus y cube plus 27z cube minus 18xyz. All right. So this is looking like the left hand side, a cube plus b cube plus c cube, or x cube plus y cube plus z cube minus 3xyz. X cube means 2x cube, right? Y cube means y cube, z cube means 3z cube, and this is x, this is y, this is z. So plus of minus of 3, what is x, 2x, what is y, and what is z, that is 3z, right? So this is left hand side, so just equate it to the right hand side. What will you get? X plus y plus z, it means 2x plus y plus 3z, right? And the next one will be x square plus y square. What is x square? That is 2x, it means 4x square. Y square means y square. Z square means 3z square, that is 9z square. Minus xy. X is 2x, y is y. Minus 2xy. Minus yz. Y is y, z is 3z. Minus 6 or minus 3yz. Minus 3yz because there is no 2. And minus of zx. Z is 3z and x is 2x. So 3 2s are 6xz minus of 6xz. So these two are the factors of the given equation which we have formed using the identity number 8. So with this, the chapter polynomials is finished, and all the concepts like zeros of polynomials and factorization, algebraic identities are covered, and you can watch the previous videos to clear your concept. Division of polynomials is very important for you. So now you can start doing the sums of this exercise, and if you find problem in any of the sum, you can DM me on my Insta ID which is given in the description. You can also use the comment box. All right, so keep practicing and don't forget to practice maths regularly and watching my videos regularly, and don't forget to press the subscribe button as well as the bell icon. All right, now we will meet in the next video. Till then, keep practicing mathematics and happy practicing.